Hello guys, welcome to another video from Computer channel. In this video, we're gonna solve the first problem from section 2.1 from CLRS textbook, and actually this part is about the basic concept in algorithm that we start with sorting an array with insertion sort, merge sort, and after this, in another chapter, we will read about quicksort and something like this concept. And here we're gonna solve an example about insertion sort, and we're gonna sort an array with this algorithm. So let's solve it together. Okay guys, as you can see here, and this is the question. Using figure 2.2 as a model, illustrate the operation of insertion sort on the array that this is our array. We have 31, 41, 59, 26, 41, and 58. And first, let's take a look at the basic and better I say pseudocode of insertion sort. Here, this is the insertion sort. As you can see here, first let me tell you something. In pseudocode, our index will start from 1 and go on. But in some language like Python, our index starts from 0. So uh, actually, this note is so important here. So actually here we will start from our second element for j to actually a dot length. This is our index of our second element here, and we will put it as our key here. After that, and we will define I as j minus 1, and we will define a loop with this condition here while I is greater than 0, or better we say greater or equal to 1, and the index and this index of a is greater than key, we will swap these two elements here, and we will actually define I is equal to I minus 1, and we will go on until we reach an element that key here is greater than a dot I here, or our I reach 0. So this is the basic concept of insertion sort, and we can assume that we have a play card here. Assume that we want to play a card game, and each time we pick a card from ground, we will sort it in our hand, and we will go on. This is basically is so much like insertion sort. So first here, let me code this algorithm here in Python and actually solve this question with coding. So let's go for coding. Okay guys, as you can see here, this is our array. We have 31, 41, 59, 26, 41, and 58. And we want to actually define a function that we call it insertion sort here, something like this. And our input is our array. So yes, this is our input. First, we have to calculate the length of our array, the length of our array, better I say. So we define n, and yes, something like this. After that, we have to actually define a loop that this is something like this for I in range actually 1 to n here. Yes, something like actually better we say n plus 1 here, because we know that assume that here the length of our array is 6, and um, actually in Python that when we define the actually we use from range, we don't go to the last element that we have here, so we don't reach n, or better I say 6 here, so we must define it as n plus 1. So yes, this is true. After that we define p to it is equal to actually the ice element from the array here, and we define j that is equal to I minus 1. And here we have to define our while loop that we will continue until that here actually j reach 0, and in our loop better say that the key must be here. The key must be actually lower than the base element of our array, so it will become like this. If we meet this condition, we have to swap our element. So we define it like this, and we have to count down the j like this. And finally, when we meet our condition here and we exit the while loop, all we have to do is that swap the j plus one element with key here. So yes, this is the basic algorithm of insertion sort, and it's better say that here we print we can print our array, or if we want, and here it's better say to define it as in here, and here we can print our array. So because the insertion sort is an in place algorithm, so we can print it. So if we use from insertion sort of array, actually here we have a problem. It's so bad. um Here we can, yes, yes, sorry, in the for loop, we have to define it until n, because we know that when we call the len actually function here, it will count until the length of our array plus one. So it basically has that condition that we don't reach the last element here. So yes, this is true. And as you can see here, it sorted our array, so it works. So if you want to see every part of our algorithm step by step, we have to define print here. And again, if we call it, as you can see here, in the first order, what we do, actually, as you can see here, we know that 31 and 41 are sorted. Actually, the base condition is that we know that if we have only one element, it is sorted. So yes, it is okay. But after that, if we add another element, like here 41, we know that the 41 is greater than 31. So it's basically here is sorted. So it won't swap anything. And after that, if we add 59, still our actually a smaller array is sorted. So in the second line we didn't swap anything, but in third line, as you can see here, we know that 26 is smaller than all of our array here, because 26 is smaller than 31. So all we have to do is that we have to shift the 26 to the first index of our array, and we have to shift all of an other element one bit to right, so it will become like this. And after that, we know that the 41 is actually smaller than 59, so we have to swap both of them here. It will become like this. And finally, we know that 58 is smaller than 59, so all we have to do is that swap them, and yes, we have the final and sorted array here. And this is the final solution for the first question of section 2.1 from CLRS textbook. I hope you guys enjoyed this video and learned a lot of things about insertion sorts here. Actually, I know this algorithm is so simple, but we have to start from this basic concept, and after a no, not a long time, a short time, we will reach advanced algorithm and other things that is so uh, actually better I say, I don't know, maybe lovely or something like this. So yes, that is, I hope you guys enjoyed this video. If you like it, like the video, and don't forget to leave the comment in comment part. I will read all of your comments, and you can subscribe to my channel. It is a big motivation for me. And yes, that's it. Have a nice day, guys. Goodbye.